Hello everyone, this is lesson 11.6, cross-sections and volume of prisms and cylinders. So we don't do lateral area or surface area anymore because for your air test and on the standards, it only wants you to do volume. So that'll make the lesson a lot simpler, it'll make your homework a lot simpler, and what we're learning today will help you with the next day's lesson, 11.7, on pyramids and prisms. So a cross-section, hopefully you have the notes. They should be printed off and handed to you. A cross-section is the intersection of a plane and a 3D figure, like this one. So here, this is the plane and this is the pyramid. It can be any 3D object. And the cross-section is the shape that's made from their intersection. So here the cross-section is a triangle, as you can see. So this says, describe the shape formed by the intersection of the plane and the cube. So for A, it would be a square. It's a square. For B, that would be a rectangle. Because now it's going diagonal, it's not, this looks like it's parallel to the base, which means the base is a square, then the cross-section is a square. This one's a rectangle. And then this one, if you look carefully, so these two, or this is going to be parallel to this, and this looks like a trapezoid. It's a trapezoid. Okay. Here we've got a triangle. This intersects the cone and makes a circle. And here, this would be a hexagon, 6 sides. All right, so on to the next lesson. A polyhedron is a solid that is bounded by polygons that enclose a single region of space. I think that might be the word I was looking for up here, a 3D figure or a plane and a solid figure. Another way to describe a 3D figure. I do not have my answer key with me, so forgive me if I make a mistake here and there. Hopefully I will not. And then a polyhedron with two congruent faces called bases, which lie in parallel planes. That's a prism. So a prism is different than a pyramid because a pyramid has a base and then it comes up to a point at the top, but a prism has two bases that are parallel to each other, and then the lateral faces. So some of these terms we don't have to worry about, like the lateral edges and the lateral faces. That's more for finding surface area. Just the base part is what we are interested in. I guess you do need to know the lateral because you need to know the height of the base when you're finding the volume, because volume, as we see, involves height. And then you could have a right prism where the lateral edge is perpendicular to the base, so this would make a right angle here. Or you can have an oblique prism. So careful when you're finding the volume of an oblique prism is that the height, this is the lateral height, but this is the actual height of the prism that you will use when calculating the volume. And then this would be the base. I can't tell if the rectangle is on the bottom or if the triangle is on the bottom, but that doesn't matter because the base is still the part that has two bases parallel to each other. So these are the bases. Even if it's on, if the rectangle, this rectangle here that's shaded is that's what it's sitting on, I can't really tell, but the triangles are still the bases. And then the volume of a solid is the number of cubic units contained in its interior. So remember, when finding volume, it's always units cubed. Oh my goodness. Okay. So we're not going to worry about lateral area or surface area. We're just going to worry about volume. So volume is the area of the base, which we use capital B, times the height. Okay, so for this one, your area is, the base is a triangle, so you would use 1/2 base times height of the triangle. So that would be your height, and then times the height of the prism. And then for the other one, the base is length times width. So it's length times width times height. For a cylinder is basically a prism, but the base is a circle. So when you take the volume of the cylinder, you're just doing area of the base, which is pi r squared, times the height, which is h. So not different, just you have a circle as your base. So let's do some practice. Let's find the volume. We're not finding the area. We're just going to find the volume. So we're going to do 1/2 times base times height, because this is a triangular prism. Like I was saying on the other slide, even though it looks like the rectangle here is what it's sitting on, the base is defined by the two parallel sides. So it's a triangular prism. So 1/2 base times height, and then times, you can say big H for the height of the prism, which would be 12. So 1/2 times 5 times 8 times 12. So we can do this in our head. This is 40. 40 times 6, because 1/2 of 12 is 6, would be 2,400. And then, 240. 240 feet cubed. Okay, easy enough. For number 2. So there is a formula for finding the area of a hexagon, but I don't like to teach kind of random formulas that you might forget. Instead, what we're going to do is find the area of one of these triangles, and then you see there are 6 more triangles throughout the whole hexagon. So this would be an isosceles triangle, and in this isosceles triangle, this is 8, and this is 8. So if we want to find the area of this, we would need to know what this height is. Okay, and if it's isosceles, that means that the perpendicular is also a bisector, so this would be 4. So now we've got the case of the Pythagorean theorem here. So we're going to find little h. We'll do h squared plus 4 squared equals 8 squared. So that would be 16 plus, equals 64, minus 16 on both sides. That would give you, 48? And then take the square root of 48. .928. See, 6.93. I'll keep it to 2 decimal places until the end when it says rounded the nearest tenth. Okay, so now we can go back, and if there are, remember, volume is volume of the base, or area of the base, times the height. So for the area of the base, we have 6 isosceles triangles that all have 1/2 base, which is 8. So times 8 times the height, which is the 6.93. You could also just leave it as the square root of 48 and just type that exact number in. You'll get a better answer. And then times the height of the prism, which is 11. So I might simplify this a little bit. It's like this is 4, so that's 24, because 6 times 4 is 24. Square root of 48 times 11. But then I'm just going to type that into my calculator. So 24 times the square root of 48 times 11. Make sure to get out of the square root. 1829.0 meters cubed. Okay, moving on. Find the volume of this. So here we have a cylinder. So we're going to do area of the base is pi r squared. So r squared would be 25 in this case, times 12, round to the nearest tenth. Okay, so just type that in. Pretty easy. Pi times 25 times 12 is 942.5. Wait, yeah. And it looks like that's all. So, hope you enjoyed this lesson. I will see you guys tomorrow. Have a great day.